I try to make my projects look fun, and if not easy, then at least straightforward, with the Raspberry Pi Pico. Projects rarely go exactly to plan though. I take wrong turns all the time and get stuck and have to take a different route. I even break things. There's a common set of mistakes that I make, and I suspect lots of us do, and I think they can be avoided. I want to share with you some of those mistakes and how to avoid them so that you don't have to lose as much hair as I have. So let's avoid these issues together. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, robotics, IoT and other fun tech. This is a slightly different video as no code repo or build is involved. It's a set of anecdotes and hopefully useful learning on how to avoid some of those build issues that you might have so your projects can go a bit more smoothly. Are there any other mistakes you've made that you would warn us all against? Please let me know in the comments. We want to share in that knowledge and avoid these issues. If you like the video and it helps your learning or projects, why not buy me a virtual coffee or lunch or a holiday or two? Use the super thanks button below the video. Please do hit the like button on the video too if you enjoy it, and subscribe for more. I do appreciate it. This video is sponsored by Cancun. Cancun is a friendly retailer in the UK for modules, components and electrical equipment. Cancun has kindly offered a discount to my channel viewers on the first order. Just quote Dr. John EA20 at checkout to get a 20% discount. This excludes electrical test equipment and tools. If you're in the UK, go and check out Cancun today. Connectors are often the bane of my life. I spent days fixing bugs in code that turned out to be dodgy connections on a breadboard. If I had hair, I'd have pulled it out. I think there are two connector problems, for me anyway. My first is often working out what type of connector XYZ module is using. I had this recently on the X-Arm S1, trying to work out what the serial connector was on the board. Turns out to be a Molex 2.5 connector, but I had to ask someone as I didn't recognize it. There are lots of different connector types, and unless you know the name, it's almost impossible to search or buy them. Even if you can match pictures, then size comes into it. The size is normally measured in terms of the pin pitch or gap between the pins. That isn't easy to measure either. Really, you want a whole set of these examples to try and see which fits. But that's hardly helpful advice when you're just starting out. The second potential issue I think with connectors is that the connections fail. A wire breaks inside the plug, or worse still, an intermittent signal through it. These can be really problems. I often get these intermittent issues when working with breadboards. As breadboards get old and the socket springs get weak in connecting and not strong enough, I really need to replace these breadboards when they age. I use a lot of DuPont connectors as they are fairly easy to make and I have the crimps and parts for them. These are cheap as well and great to get going, but they're not very secure. There's no lock clip and the wires often shear off within the connector if they're treated roughly. JST plugs are more secure, but come in such a large variety, it's often difficult working out which ones you have. The first piece of advice here is that you're not alone. Tim Hunkin, the guru of makers, talks about the same problems in his series of videos, The Secret Life of Components. Here's some excellent advice and I highly recommend watching it. When it comes to recognizing connectors, then this is just an experience thing, unfortunately. But the great thing is that we have social media now, so there's always someone out there who can give you some advice and answer the question of what that connector is. Okay, often two or more people will have different answers, which is more challenging to work out, I know. Connectors become an issue in prototyping when you have large numbers of them, particularly on a breadboard. I've learnt to try to get parts of the project working and then move it onto an adapter board, even if these boards are temporary. Moving it onto a more permanent soldered board just helps me have a secure set of connections that I know work for that portion of my project. Spider-Man said, "With great power comes great responsibility." He was so right. I don't always realise when I've got a dangerous power level though. It's just too easy to step up to that level. When I first started with the Raspberry Pi Pico, I started playing with WS2912B LEDs, or NeoPixels, as one of the manufacturers calls them. I wanted to use 144 RGB LEDs in a 1 meter strip as a lightsaber lamp. I knew this was going to draw a reasonable amount of current, so I had a decent power supply for the strip. It was all plugged through a breadboard, and at that point I was using whatever wires came to hand for my jumper wires. So often stripping out Cat6 cable, which I had lots around, to use as my connector wires on the breadboard. So with 144 RGB LEDs brightly lit, I noticed smoke drifting across my desk, and of course immediately panicked. I'd fried my Pico. But actually my Pico was fine. What I was doing was burning insulation off of the Cat6 cable by drawing 5 amps of current through it, way above what it's meant to be drawn at. So when you start pulling large current, then you need to think about what cable you're using. There are good guides online telling you what AWG size you need for different current loads. I've also recently melted a breadboard with high currents, drawing through it as well. I was playing with a stepper motor and drawing 3 amps. My control circuit was misbehaving a bit, and it generated quite a lot of heat onto the breadboard, causing some of the breadboard to melt. So be aware that currents you're using and use the right gauge wire. It's really important. The internet is full of such amazing components, from screens to memory chips to communication modules, servos, sensors, etc. I just want to buy them all and try them out, don't you? Of course, the first question is, will it work with a Pico? And 99% of the time the answer has got to be yes. Of course it will. But this is the wrong question for my projects. The question should be, can I get it to work with the Pico? I bought a crypto accelerator I2C device. There are a few available on the market. It was in a sale and I did less research than I should. I thought I'd seen it working with the Pico SDK, but actually I'd seen it working under Arduino. I spent 3 days working on porting the code and never got a peep out of the device at all. Though I've not entirely given up, it does show that these things are not quite straightforward. I bought a nice TFT display for a project with the Pico, 320 by 240 pixel display. I did do my research here and knew that it wasn't going to be entirely straightforward, as there was no polished library for the Pico. There were though 3 or 4 community projects that looked like they worked with it. Close call though, because when I actually tried these projects I found that the number of boards available was actually much larger in their variants than I had thought. And I could only get one of these projects to actually work, and that mirrored the screen. So I actually had to go back to first principles and write this from scratch, using both the library to help me and the documentation. The key to getting components working with the Pico is to do your research. Are there quality libraries and projects as examples that demonstrate working with exactly the component we are buying? If you can just follow a tutorial to get it working, it's going to burn much less time. Yes, we can get almost any component or module to work with the Pico. The time taken to do this may be significant though. I use code repos off of GitHub all the time. I use it for sharing my code and for bringing libraries of my own and others into my projects. It's great. It's also a version repository of the stages my projects have gone through. It's really useful to be able to wind back quickly to a working version of my code and then to move forward from there. That just requires that I check code in each time I hit a nice stable working version. Do I do this? No, of course I don't. I've lost so much time on projects trying to manually backtrack to working versions when I decided the current strategy isn't going to work, or when I accidentally delete code from a project or overwrite it. Perhaps I'm getting old, but I often mistake which project I'm in and accidentally copy files into the wrong place. It can then take me hours to recover. I've never yet got to a point where there has been too many versions checked into my repo. Just this never happens. So why don't I check in more? So my advice is to check things in often, at least every time you get a working or near working bit of code. Also at the end of the coding session, try to check things in then. I find that when I start cold on a new day is the most likely time for me to accidentally destroy stuff. Assumptions kill. I try to work at some pace with my YouTube broadcast schedule, my course development and some consultancy. I can't hang around for too long on a project. This means I tend to make assumptions, and sometimes those assumptions are wrong. When I worked on the Cosmic Unicorn animated display, I brought together two working projects, one to read from a USB file system and one to display an animated PNG file. I thought that was going to be easy, just bringing those together. But I made some assumptions that the USB hardware and the display hardware would not interact. In fact, they did. They both tried to use the same DMA channel at the same time. If I'd researched the code a bit more, then I would have found that out, and I could have saved myself some time. For Pico projects, we're really lucky as we have all of the source code for the Pico SDK and certainly for every library I've used so far. The code is the truth, though I do read the documentation, and I really do love it when library providers write decent documentation. I also check out the code, as sometimes the documentation does not cover all of the possibilities. So take note of your assumptions and do some research to avoid issues in your projects. It's not uncommon for me to get halfway through a project and realise I need to do some surgery on the foundations, that what I set up just won't work fully for my project. If I have designed things well and it's componentized, then I can replace a software component in quite a straightforward way. But testing it all works though can be a lot more work. Here is one of the big benefits in my mind of test-driven development, and having a regression set of unit tests that I can run against my changes. I can then quickly test that the changes work in all of my test scenarios. I've done a few videos on using CPP-U-test as a unit test framework that you might want to check out. Unit testing and having that pack of regression tests really helps me in being able to refactor my code and therefore develop at speed. I'm sure there are lots of other potential pitfalls in your projects. I'd love to hear your examples of what not to do and how to, avoid these stumbles in the projects. Please add a comment below and tell me your mistakes and how to avoid them. We all want that learning. If this video or any of my videos helped you out, why not buy me a virtual coffee or lunch? I'd really appreciate it. There's now a super thanks feature live on my channel videos. Just click the button underneath the video. Thank you very much for watching. If you enjoyed the video, then why not hit that like button? It gives me confidence to make more. And please subscribe to my channel so you don't miss the next video. Goodbye for now.